When the output is short circuit, there is short circuit current condition. That time this IC dropped its frequency at 56 kHz. It is waiting until the short circuit condition or overcurrent condition is finished. When this condition will finish, it will receive feedback. That time this IC will restore its switching frequency at the nominal switching frequency, that is this time 333 kHz. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session we are discussing function of this DC to DC converter. It is a buck regulator. It is using LA8522 IC, that is step-down DC to DC converter, Schottky rectifier, these capacitors, feedback network, current limit circuit, inductor, one input capacitor, one output capacitor. So this is the circuit. Most of the time this configuration is used in disk drive power supplies, in set-top boxes, satellite receivers, DVRs. Let's see how it is working. LA8522 datasheet. LA8522 Step-Down DC to DC Converter. Download datasheet. LA8522 300 kHz 2 ampere step-down DC to DC converter, 23 volt, 3.6 volt to 23 volt input voltage, output 0.8 volt to Vin, continuous 2 ampere current, 300 kHz oscillation frequency. Here is sample circuit. Pin number 4 input voltage, pin number 2 enable, pin number 3 current set, pin number 5, 6 switching, and pin number 1 feedback, pin 7, 8 ground, 5 volt 2 ampere operation, 6.8K and 1.3K resistor combination, 2 resistors as a voltage divider network. We can adjust its output. There is calculation formula, we can calculate it and we can adjust the output as well. And here is 1.8 volt 2 ampere operation, 2.5K and 2K. It is quick design table. Input voltage in the top row, and here are outputs. We can select output if you want 1.2 volt output by providing 5 volt input. This inductor value, R1, R2 and R3, 3 resistor values. If 9 volt input and output is 1.2 volt, then these component values are used. Block diagram here, in and switching output. Here is PWM switching control circuit and feedback is applied here. Enable pin is here, current setting here. Pin definition, normal recommended operating condition 3.6 volt to 23 volt. Switching frequency may vary from 240 kHz up to 360, typical 300 kHz. If there is overcurrent condition, there is short circuit, it will work at 50 kHz. So it will search for clearance of the short circuit. When short circuit will be removed, the switching frequency will restore again to 300 kHz. In our case, it is 5 volt 2 ampere circuit. Here is input jack. Ground positive. Positive voltage are reaching to positive terminal of this capacitor. And ground is connected here. Positive voltage here, ground is reaching at pin number 7 and 8 from inside of the PCB. So capacitor will store charge, then this fuse resistor R7, jumper resistor, then here is switch. When this switch is turned on, the voltage will pass from this point to this point. When this switch is on, that voltage will reach to this point and it is connected at this capacitor. This and this. This end is ground. Here is capacitor. That is this one. 220 microfarad, 16 volt. When this IC will start switching, it will provide switching from here to this point at 300 kilohertz. This voltage will pass through this inductor. The magnetic field in this inductor will build up and collapse at 300 kilohertz. The same way, here is freewheeling diode. The voltage will be stored at this capacitor. That is this one. This one. Here are two resistors, 6.8K and 12 ohms. Feedback resistor. This end is ground, this end is output terminal, and this point is reaching to pin number 1 of this IC. Yes. Pin number 2 is enable signal. It is pulled down using 10K resistor. This 3.3K resistor is connected at pin number 3. Let's check it now. This end is ground and this one is positive input terminal. Voltage are reaching to this capacitor and this end ground is reaching at this point. This voltage passed through this jumper, reached here. This time the switch is turned off. So voltage are not passing to this side and this point. Now I will turn on the switch. Now voltage are here and voltage are here. 12 volt input. The same voltage are now passing at 300 kilohertz switching frequency, and it is switching that voltage and IC is dropping 4.9 volt. So we are receiving these voltage here. Now we will check frequency. Now I will connect two jumpers. One jumper at ground terminal. Oscilloscope ground here. Here is high signal. Now I will switch on. This time this IC is switching at 324.7 kilohertz. If I will make short circuit in the output, it is switching at 56 kilohertz. When the output is short circuit, there is short circuit current condition. That time this IC dropped its frequency at 56 kilohertz and it is waiting until the short circuit condition or overcurrent condition is finished. When this condition will finish, overcurrent will finish, it will receive feedback. That time this IC will restore its switching frequency at the nominal switching frequency, that is this time 333 kilohertz. kilohertz. If I will connect load, when I am connecting load, it is changing its duty cycle. This time, no load, 42% duty cycle, 44%, 45%. I am connecting this NTC so that the load will increase. When it will heat up, its resistance will decrease. So it will draw more and more current, and now we will see the response. 45%. How it is dropping the voltage. I applied 12 volt positive here and ground here. Here is converter. When we apply 12 volt input voltage, this IC will turn on and it will allow current for very short time, 300 kilohertz. That means 300,000 times in 1 second. When voltage are maintained, it will receive feedback. it will turn off switching. When switching is stopped, now it is disconnected. Before this, when current was passing, this end was positive, this end was negative. Now when magnetic field will collapse, this end will become negative, this end will become positive, and here is load resistance. When this IC is now off, this end will become negative, this end will become positive. That time this diode will give discharge path to that stored magnetic field. When it is switching, it will provide dropped voltage here and current will flow in the load. When IC is off, stored magnetic field will be discharged through this winding and it will become ready for next pulse. So these slices are provided to this capacitor. 12 volt slices at this rate will provided to this capacitor to provide regulated 5 voltage. So it will run the load in this off time and we will receive regulated 5 volt for the load. If the voltage are dropped due to load variation, that time this feedback network that is connected at pin number 1 will give feedback that voltage are dropped. That time it will increase this switching time so that more long pulses will reach to this capacitor, so that voltage variation will be compensated. I hope this video is informative. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.